Bullshit, I can't hear you. Sound off like you got a pair.
Hey, Gumby, what's happening, brother? Dude, I finally got the narrative section of the report done, and that was a beatdown. I'll tell you about it once the stream kicks off. But yeah, I finally actually wrapped it up this afternoon. Oh man, I didn't start the timer. That's alright, hold on, we can fix this. Fast forward. There we go, that's good enough. You got a 15 stream watch streak? Nice. Let's see. Just getting everything set up. I think we're good to go. Let's do a little bit more of fixing Le HackBot. All right. Oh, I missed a timer. Let's kick it off. Oh, wait. Hold on. Is this thing turned up? I don't know. We're going to find out. Let's see if it works. It's going to probably broadcast the wrong screen anyway. It sure did. That's the stream monitor, which isn't it's a vertical config. So it's like, and it's 1440p, right? And it's trying to compress this all down into 1080p on the stream. Piece of crap. I forgot to check that before we started. Wait a second. Can y'all hear me? Okay, good. I was making sure the microphone was actually working. Stand by. Let me change the video source here. Where is it? Where's the thing? Where's the button I need? That's audio source. Hang on. I know what I'm going to do. Stand by. It should just automatically start up. Let me restart this system real quick. There we go. Now we're back on the proper screen. That's funny. I forgot to double check that because there's 3 screens on this computer, and sometimes it always wants to go to the other one. All right, let's see here. Dude, I'm still brain fried. What's up, everybody? I hope y'all are having a fantastic Saturday. I have been working more this week than just about any other week because it's report writing week, which is always a bit of a beatdown. So, on the plus side, though, part of the reason why things were taking longer is because I was actually working on some interesting toolkit to help out with report writing. So we have some pretty stringent reporting standards where I'm at, and it can get very demanding trying to like correlate certain pieces of information. So I was working on something to help boost that up and make it simpler. So in the result of that is in the future, reporting will be faster, but it wasn't for this week. So I just finished, let me think about this. So basically we had to outline in a narrative section all the different attack paths that we took. And hey, Drewski, what's up, brother? We had, let me think. We had 3 different environments, so that's at least 3 attack paths. We had 2 additional objectives on top of that. And actually, we found an additional path in one of the environments. So there were 6 narrative sections that I had to write before this report. So it was a little bit of a beatdown on there. But Drewski, the problem is OBS isn't on this computer. OBS is on a second computer. So what I have is a system called NDI, which streams this computer's monitor over to the secondary computer. And the problem is NDI will sometimes get confused after I put the computer to sleep and I wake it back up and it will start capturing the wrong monitor. So that's what happened. So I do have the lab up and ready. I was getting ready to kick off the seed run just because it's practically muscle memory at this point. But I remembered, I was like, oh wait, we're actually working on how to get the state management cleaned up. So, do I still have the document for that? Yeah. Hey, I do. Here we go. So here's one of the issues that we're running across is that if we modify anything in the state table in here, we actually, if we modify this, we had to go do, it was actually pointing to a memory address and then modifying it. So instead, what we were doing is making it so where we make copies of the objects, then we can modify the copy and then re-emit that back over to the state table. So I was just looking through the commit we did last weekend and trying to look at it. I was actually really hoping I was going to do another Alan Wake stream, see if we could finish it off on New Year's Day or New Year's Eve. I was just dunzos. I've been working till 2, 3, 4 in the morning this week. Let's see. Yeah, so for example, here's where we were cleaning up a couple of things on how we're referencing the state table. Let's see. Yeah, so we changed it from state to output. Okay. Now, where did I do this, actually? Output current task. Yes, actually, so here's something else we did. So we usually will have something like these helper messages in here, or these helper variables where we can go through, we can track things. So one of the things just from a design perspective is we started creating outputs for all the various primary keys we're going to emit back in here, like this. So that's what we were kind of doing. And also we'll probably have to go implement some new reducer functions, but it'll be all right. It'll work. I know it was you, Gumby. I said hi to Drewski, and then I answered your question. Oh, I got the hookup from 8-Bit Oni. He told me Vitamin Shop has Jocko's for $1. So I got a new flavor to try. What is this? Blue raspberry. Yeah. It doesn't taste bad. It's a little on the sweet side for me. But that's the time to go try out new flavors. All right. Where did we leave off? I think there was another one in here with the state table. I think what I want to do is this. Let me grab this. We're going to do a partial seed run to kick it off. So let me get my test data. Let's go drop in our IP address here. And let's do this real quick. Because what I want to do is get a clean run from where we were last time. So we'll start over here. Essentially, once it gets... I'm going to let it run to the beginning of the exploit agent, and then I'm going to kill it. So after it does the pickle function on exploit, I'm going to stop it. Oh, you know what I didn't do? I usually go check and make sure this IP address is actually reachable real quick. Let's double check that real fast. You can't see it because it's behind me right now, but trust me, it's there. If I copied the IP address correctly, anyway. What is this bad request? Bogus? Alright. I also did not restart the LangGraph server. I might have to do that. But anyway, let me grab this IP address here real quick. Let me make sure the VPN is up and running properly. Wait, there it goes. No, that wasn't the correct IP address. Okay, it is up. Sweet, see right there. Boop. Okay, so the VPN's up and working. I think let me close that out. Don't need that. I think I need to go ahead and actually kill the LangGraph server. Credit balance is too low to access the API? What? What? No. No, no, no. I should still have API credits. Hang on. Stand by. Let me go fix this. Some bogusness. Where's my billing here? How would I run an API credits? This makes no sense. Oh, you know what I think I know what happened. So one of the things I've been doing is I've been going through and I don't know. I'm not sure. Well, here's what I think happened though is because I see a huge spike on what day was this? December 22nd. What was the 22nd? That was a Thursday. And I wasn't streaming on a Thursday. So I think I know what happened is I've been working on building some script generation stuff for YouTube videos. And I was doing it in Claude Code. The Claude Code API key is tied to the API key that is for my Anthropic instance, right? And so when you hit your usage limit in Claude Pro, you can tell it to use extended usage using your API credits. I think I accidentally did that and chewed up the last of my credits. Because there's a spike. Hang on one second. I'll show this to y'all. Here's the actual dashboard right here. Because there's nothing sensitive on here. But look at this. It's like, okay, yeah, that was the 14th, the 15th. You know, a couple of small, and then all of a sudden there's ka-chow. What was that? 1.3 million tokens. I'm like, what in the crap was I doing there? So I think what happens there is when you run out of usage during your 5-hour time block on Claude Code, you can tell it, hey, we're going to wait and chill out until the usage resets, or you can tell it to use your API tokens. I think I accidentally told it to use my API tokens during one of my deliriums one night. It used up all of them. Oops. All right, hang on. I got to go back into OPSEC mode. I got to go re-up the billing in here. Let me see. Thankfully, this shouldn't take very long unless their servers get overloaded. I probably didn't think anything about it too because the folks over at Anthropic did a thing where they doubled everyone's usage limit, I think for the last 2 weeks of the year. And when they did that, and it was just churning extra before I hit this limit, because I had it going over transcripts from the news streams. So actually I went through and had it pull audio and then transcribe that audio from all the news streams. And then I've been working on agents to go through and define like, hey, what are the segments that we talked about? And then pull the transcripts for those particular segments and then work on turning those into YouTube scripts. So I've got a long list of them that I need to go through and analyze and see how well it did. So I can go through and I can clean it up and provide feedback. But yeah, so that's what happened. All right, let me drop back out of OPSEC mode now. Oops, indeed. Hey, Frozen. What's up, man? Happy Saturday. Let me see if I can just tell it to continue from here. Rerun from here. There we go. That'll work. There we go. Now it's cooking. All right. Actually, I'll tell you what, I'm just going to let it get through recon for now. When it gets through recon, I'm going to kill it. We'll go look at the trace. Because what we need to make sure of is that data exiting one node identically matches the does not match, or it does match the entrance to the next node. So thankfully, there's a visual tell in the LangGraph studio, or the LangSmith studio, or just LangSmith. I'm getting the terms confused. There's LangGraph studio and there's LangSmith. LangSmith is the traces. This view right here is the LangGraph studio. But there's a tell in LangSmith right here for the traces that will tell us when something happens like that. Okay, let me cancel that. Enum's done. see. Yes, Happy New Year. Also, yeah, first stream of the year, everyone. And I really did not want to miss it. I'm going to be out of town Wednesday, so there won't be any new stream this week. But I've got a long list of articles that I've put together for the news stream on the 14th when I come back. So we'll have the regular Saturday and Sunday streams. I just won't have one on the 14th. Why does it still say this is running? You're canceled. You're no longer running. Jeez. There it goes. All right, so let's take a look. So here's what I'm talking about. If you look at, for example, the Stinger agent here, you have an input that shows us everything in the state table as it comes into the node, right? So if we look right here, we have, these are all subgraphs, but you can essentially think of them as being summarized into a node, right? So if the data comes into here, actually, let's just go back over to here. This will make it a little bit simpler to kind of look through. There we go. All right, so for each of these nodes, it's an independent function, right? So if we look at it, we should get two copies of the state table. What does it look like going in, and what does it look like going out? If the output from Recon does not match the input to the Recon tool node, for example, then we know that the Recon tool node is incorrectly accessing the state table and is updating it outside of the return value. So a little bit of a cheat method that we can use there. So here's what we're going to do is we're going to try to go and compare these just a wee bit. So for example, let's go take a look here real quick. Let's look at the code. So the only thing that the Recon agent, and in fact, let's do a little bit of work in here. So if we look at just our return statements, right? So we've got a couple. Returns messages. This one returns messages and a current task. This one returns messages. Let's see. This one returns these four right here. So what I'm going to do is I'm going to put a doc string on it. That's the easiest thing to do. No reason we can't put a doc string on it. So what we're going to do is Recon agent. Which one is this? This is the primary task handler. And then what I'm going to do is I'm going to put like, hey, this is what our output should look like. Just like this. And there we go. So let me bring this down, bring this in, bring this in. Actually, I take it back. This looks like butt. Let's take that in a little bit. There we go. We'll call this our output mapping. So what this will tell us is, what do we have for our primary key, and how is that being mapped to the variables in here? So we'll kind of prettify this just a wee bit. Like that. There we go. So now we know, okay, if we need to return something to messages, this is where it's going to go. Just like this. All right, let's go see if we can find anything in here that's incorrectly matching like what is being returned. There shouldn't be anything. And in fact, I think back here, aha, so there is, actually this is down in the output formatter. So what this regex right here says is, look for anything that kind of starts with state, like we're referencing the state table, has some various matches to it. So does it have like a left curly bracket in here? And does it have only one equal sign somewhere in the string? So this one matched. So in this case, what we did is we used this add messages in here, which is absolutely terrible bad. We don't want to do that. But I think that is, there's 4 of these used in here. So there's 1, 2, I think 2 of them in output format. No, one's in the validator. So like the validator, we don't want the pre-flight check set to true. This is actually not a problem. We can take this and we can hard code this down into the return. That's no problem. What else do we have? And so this one is also in the validator. These ones we need to change. We need to go put them into independent variables. And that's it. Okay, not too shabby. Not a heavy lift in here. And see, this is how we used to do it. Return, and then we return a portion of the state table to it. But that's not what we want to do. So let's come back up here. And let's see. So in this case, for the output formatter, we're going to do the exact same thing we just did before. And this would be... I'm just going to call it the output formatting node. Just like so. And then we'll tell it this is our output mapping. So what this is going to do is just tell us what we're mapping to each of these return values. So for our return values, we've got these options right here. So we'll bring this up. We'll do a little bit of doc stringage. Take that out, and make it pretty. There we go. So we don't want this right now, though. Having all these state values is what's going to mess us up. So here's what we need to do. We need to actually define this as output messages. And then we can go through, now we can define what we want. So let's call this output host. Let's see. Just like so. And then the same thing here, output tasks. So all of the values that we're going to return, all those placeholders are going to be these output values. What about tasks? Just like that. Boom. There we go. Love the shirt. Thanks. So all of my nerd shirts are super old. I'm going to say it was Sorcerer. I mean, that's how I'm going to read it. And yeah, so the wife got me this. It's even got the dollar prompt down there. So that was her Christmas present to me. Was she let me pick out a whole bunch of new nerd shirts. And she's the worst about going clothes shopping, actually. Her clothes are just as bad as mine because we don't ever want to go clothes shopping. So, but they're all getting old and ratty and I love them, but they're just wholly. And so she's like, okay, you need to get new shirts and retire some of them. I was like, man, some of these are vintage though. They're older than my kids. Code Sorcerer. Nice. Very nice. I'm a code pooflinger. That's what I am. I don't do coding as my day job. I work as a penetration tester and red teamer. But I thought the idea of going through and making an AI agent and exploring that process so I learn how my customers and my clients might be trying to implement some of these things, get ideas for the design patterns, and make it go play capture the flag games would be a fun idea. So that's what we're working on. I'm not pooping, Gumby. I'm right here, dude. You're looking at me right here. All right, so let's go define these real quick. And in fact, I think I'm going to put a bookmark in here. Why don't you? Oh, you won't let me bookmark on a non-breakable line. Thank you. Clear this out. Let me see how I defined these return statements real fast. Did we not return the current task? Oh, it sees that as non-reachable code. That's actually a visual bug. It is very reachable code. It's just not always returned, but whatever. So let me grab host and tasks. I'm going to need right here. In fact, that'll probably just be output task. Let me come back down. Let's go clean this up a bit. So that'll be our output task and our output host. Because we're only going to modify one host at a time. Yeah, probably should have changed that above, but I can do that in here. Be a slight visual difference to it. And then what else do we need? We need messages. So let's define that real quick. So we'll do output messages like that. And this is going to be a type of, could be an array of, what is it? Base message, isn't it? What is that? I'm trying to remember. Let me look in the state table real quick. Any message, that's what it is. There we go. And it can be that, or we can make it a none, and we'll just initialize it as a none for now. There we go. Yeah, I know you don't have that imported. That is not correct. Do I need to specify this as a list like this? Where's this one importing it from? Yeah, LangChain core utils. Why is it not finding it? That's all right. We'll find it from up here in the imports. What is this song? Let me skip that. Ah, that's better. More chill. Especially after the week I've had, some more chill would always be welcome. All right, here's any message. I know we have tool message already in here. Why is any message not showing up? Let's see. This is from LangChain core messages. I mean, it should be right in here. Any message, yeah. I don't know why the auto import didn't detect that, but that's all right. We got it fixed. Let's see. There we go. Now we got our any message. Okay, cool. So these are the things we need to actually go through and update right here. So, and see, this was supposed to be the merge list in here. So we can't do add message. What we're going to do is we're going to take... Actually, all we're going to have to do is just append the response right here. So let's take this out. And this is not going to be this. It's going to be output messages. And... Ooh, actually, how do I want to do this? I'm going to change this. This is only... I'm going to make this an empty array. Since it's going to be an array anyway... It's just going to make a little bit of the code further down simpler. So we'll make that an array. We'll say this is just going to be an append onto meow. And we're just going to append that response onto it. There we go. Boop. Okay, awesome. So now we've got that. Oh, here's actually another one. Look at this. So this one, we're appending the output to it. So that's another one I have to look at. I think actually I could modify this where it doesn't matter if it is an entry, if it's an equal sign. We could actually change this to if it starts with that. You're not going to let me check if it starts with that? What regex is this using where the caret isn't the start value? Can I do white space? Okay, yeah, I can do white space before it. All right, well, that's fine, because what we can do is, we know there's always going to be at least 4 spaces. We say 4 or more spaces. 4 to 20 white spaces. Why is it not liking the regex? Man, every time you think you got a problem, you're going to fix it with regex, you're just adding more problems. That's what you're doing. See how they make the sausage, then tell them why it's actually poop. No, right? So this little AI bot basically comes through here, Sorcerer. I'll show you real quick. So this is using 2 primary libraries, and that is LangChain, and that is the one that handles all the language calls and all the APIs and abstraction of the data models or API structures into a nice little coherent way, sends them back and forth to the language model. So in this case, we're using Anthropic. But what it's doing here is this handles everything like for these individual language model calls. So you send text and data, you get text and data back. That's it. And then what you see right here is a rendered version of the workflow from LangGraph. So this is the supervisor right here, Stinger. And he's got sub-agents, or really these are primary agents. So Stinger's the supervisor. Recon, enumeration, and exploitation are the primary agents. So they're kind of going through a life cycle of discovering and scanning the target and then trying to compromise it. So we were almost done with the exploit agent though. However, whenever we noticed an issue. So let me bring up Recon again. So here in the Recon node, what happens is you have a state table that gets passed between each node, and each node can do whatever it wants. It's just a Python function. We can make language model calls. We can make updates to the state table. However, the updates to the state table were not super clearly defined in the LangGraph documentation. So we were modifying the copy directly. However, because it's a Python function, it's being passed by reference. So we're just getting a memory address to the object in memory. So every time we updated the state table, we weren't updating it by the correct return value. Any changes made in the code, we're going to jack it up. So now we're going through and we're backing out all those changes, and we're doing proper emittance from the functions via the return value of what actually gets updated in the state table, because it makes the tracking very difficult. So for example, over here in this this trace that we've got, if I come over here to the recon agent, I can see an input and output state here. The problem is the input and output states might not match, and they shouldn't match, actually. What we were seeing, though, is that we would see changes happening up here in what was supposedly the input state, but it was saying things that had not happened yet, if you think about it like in a linear time flow. And thankfully, that visual bug actually led us down the path of realizing what was going on with it. So now we're backing out all those changes so that hopefully now we can go finish things off and move over into the post-exploitation agent. The exploit agent actually is functionable. It's functionable. But we got to go through and clean up all the state handling now before it becomes a bigger problem later. So once these minor updates are done, we're actually going to go work on the post exploitation agent and start actually integrating it over into Mythic C2. All right, where was I? Let's see. This one is good. I'm going to take that out. So that's another thing we'll have to look for, is anywhere we use a dot append in here as well. Because I noticed this right here, the state table. Dun, dun, dun. Let me try something else real quick. So that doesn't find anything in here. Here we find some stuff where we have just white space before the state table. That actually could help us out as well. Here, let me see. Oh no, because there's white space right here, and then it could be anything. So what if we did white space star before state? And I want this to be at the beginning. Why is the regex in here redonkulous? So in this case, the caret they're talking about, it is a negation, but that should also be at the beginning of it in here. Yeah, beginning of the line. So we should say, okay, beginning of the line with some white space, repeated infinite number of times, and then a state match right here. Yeah, okay. This is bogus. Oh, because it's not. Yeah. It's using W for a word character, if I remember right. Hang on. All right. So what is the white? What's the white space constructor? Let me see. Well, you know what? I don't need it to be a white space. You know what I can do is I can tell it it's just going to be a space in here. Space repeated a number of times to state. There we go. That's going to help tell us exactly where these statements need to be cleaned up. Okay. Awesome. So like here's one we need to go fix. And so where is this all coming from right here? So what we need to do is actually go define this. And this actually is not super difficult, because what we can do is we're going to say, what is this? This is going to be our output task. We'll do output task in here. We're going to make it equal to this. Take this guy outright Tremere. And then we're going to say output task and then append. Boom. So now we've cleaned this up just like so. Okay, you know what we can do then? Fine. If you're going to be like this. There, will that make you happier? There we go. Because we're going to return the entire task anyway, so this goes and gets us the current task item in the array. That should be good. All right. So that cleans that up. I forget, in the task, didn't we add an ID tracker? I think we added an ID value in here. Let me see. Yeah, so we added an ID value. So if we just return the one task, yeah, we should be good. Okay. So let's go do this. So for task, we could just return Zevan, just like so. Untabar. All right. And then we need to go do messages here also. So this needs to change. Change you like so. Boop. And then hosts. Where do we actually make changes to the host table in here? I don't think we did. Why were we returning the host table in here? Is that just a leftover artifact? I don't think we actually... Was it ever actually modifying that? I don't think it was. No, because we're actually just appending the output to the task in particular. Yeah, because this is just the output formatter. So actually, we don't even need that. I don't think that's going to bust anything right there. Hold on. Actually, just in case, you know what I'm going to do? Like this. Now, comment that out. I'm going to leave it in, but I'm going to comment it out because I don't think it's going to break anything. Because we're not even referencing the state hosts in any of this. So if that's the case, you can also comment that out, just like so. And it's going to complain about this up here, but at the same time, I want that too. I want this to be scoped outside of this if loop in here. Cool, so that fixes that. Now, we just have to look at this. Okay, so here's one we're going to definitely have to fix up, which is our pre-flight check for our current task in here. So, we're going to basically do the exact same thing we did up here. Now, stop that. Not in use. I'm going to put a little note there about that. And I'm going to drop the same thing right here. Bring that down. Okay, so now we got to see what are we returning from this one here. So messages, we'll want an output messages in here. Messages and tasks, that's all we're doing. Okay, so we can take out the host portion here, I believe. So here's one that we've got to change real quick. So let's go ahead and get our... I'm going to grab these two, because this is the main unit that we're working in, is the messages and the tasks in here. So let's go ahead and define those real quick. And then let's go define our task in this case. So we're actually not going to make this a none in here. This has to be a task, and it's going to be this one right here. Ooh, just like that. And then we're going to modify that to be right here. And in fact, we can even reference that from our target IP right here. That's going to be the same thing as this up here. Let me change that. Normally I have that padded, so those lines should match now. Just like that. We'll match the output one. And then we do reference the target IP from the host, but actually, we had the target IP in the task, so that makes more sense to just go pull it from that. Oh, wait, I know. No, that's dumb. Actually, we do need that. I'm an idiot. Because this is pulling all the data about the host that we know from the host section of the state table. So we do want it to just be just like so. That is fine. That's not an issue. Wait, what happened to my find? That's not what I wanted. Where is it? There we go. Here we go. So all these need to get changed in here. So we're going to change that just like so to our output task right here. And then same thing for the verdict. Here we go. So look at this. We actually are modifying the host value in here. So we want to change that as well. So I'm going to put a break on that as well, so I remember it. All right, so we do need a host in here. So let's take that out. No, go away. Go away. Killing me, Smalls. Go away. So we need to define output hosts in here. And then this is going to be... what is that? How did we define that? That's a dictionary mapping. Yeah, here's how we defined that before. I'm just going to reuse that code. Because I'm lazy. Lazy dev. Alright, there we go. So now we got the variable defined. So, and then we want to go define this output host real quick. So, here's our target IP. Here's our state host IP address. So let's do... actually, I'm going to take that out. And we're going to drop it in like this. Boop. There we go. Okay, fine. You know what? Let's modify the definition then. It can be this or a host or none. There. Will that make you happy? All right, so now if we come down here, we need to modify this. This right here is going to become output host. Perfect. So now the output host verdict is going to have that appended to it. Hold on. Why does it say host doesn't have a verdicts list to it? It does. It's a list of task answers. Well, that's what it's supposed to be anyway. Rendered, associated. What did I do here? Task verdict. Oh, task verdicts rendered. A rendered verdict. There we go. Okay. Change that. I'm trying to make it less reliant on the typing dictionary. So you saw that was capital L. We don't need that anymore. This. Hey, Monkey, what's up, man? Happy Saturday. Understand, man. Happy New Year, by the way, to everyone. Let's see. Man, I tried to go take the kids to go see a fireworks show, and that's really hard, right? Because they're 4 and 7, and they said, yeah, it's going to be a little after midnight. That was the time frame I was told. It's going to be a little after midnight. It's like, okay, cool, no problem. We'll get over there. We'll chill out. I'll let the kids listen to freaking K-pop Demon Hunters for the umpteenth millionth time in the car, and we'll just wait it out. We waited till like 12:15, 12:20, nothing. I'm like, man, what the crap? So get in the car, drive home. And this is not a place very far from my house. And so we get back to the house. I go back to work. I'm still working on this report, but the kids passed out in the car on the way home. It's a 15-minute drive. It's not very far. But it was so late. Anyway, they pass out. I just basically just chuck them into bed. They're out. I go back to work, and then at like 1 a.m, I hear just like, it sounds like the sky lit up. And I go out there and I look in the general direction of where the fireworks are, and yeah, sure enough, they're just going crazy. I look at my watch and it's like 1 a.m. I'm like, are you guys operating on mountain time? What is this? Pissed me off. Should have hung it at my house. The neighbors think it's awesome to start setting off fireworks at 8 p.m. It is. And I think next year what I'm going to do is I'm going to go out to my sister-in-law's house, because that's what we did on 4th of July. And the kids just had the best time. So they live in an unincorporated section of the Metroplex, like way out in the skirts in BFE. And yeah, we just go load up. And that's what we did on 4th of July. Kids were having a great time just running around with sparklers, using them like lightsabers. And just having a good old time. And so I think that's what we're going to do next year for New Year's. Hold on, where did I define that? Let me change this. I'm gonna modify this, because it should definitely be a host structure in here, just like this. So we pull out that particular host. Okay, fine. Host or none. There. Eat it. The drone show at Reunion Center was awesome. Man, I should have just tried to let it go camp out a spot near there. That's in downtown Dallas, for anybody who's wondering. I live in Dallas. And go and take the kids to that. Let's see here. All right. Not sponsored by Jocko yet. With new blue raspberry. New flavor. I like the flavor. It's a tiny bit too sweet. But then I don't like really sweet stuff. I still don't get why it's complaining that has no... Oh, now it's not complaining. That's fine. Let's see. This is actually fine, too. To Bob. Grooving Deep. I like this one. Alright, so here we're returning our task. We don't want to return that. Why did I pull out the target IP again? We don't need that. Take that out. There's our output task, task. So this should just be our output task right here. There we go. And then we also need to be returning our output host now as well. So let's do that. So we're going to say, oh, did we define a reducer for host? Let's see. Host. Where's the state table? Host. Ah, we did a host dictionary merge. So ooh. Okay, we're gonna have to go fix this up, because this works if we're returning a dictionary. But the problem is we're not always gonna be returning a dictionary. because I want to be able to just return one particular host out of there. All right, hang on. I'm going to come back to this in just a second. I got to run to the bathroom. I'll be right back. Drank too much Jocko too fast. All right, I'm back. I'm back. I also had to go get some water since I was out of my Jocko. I had to go get my giant dad mug of water. Right there. Oh, okay. So this function is going to have to get updated right here. I'm just going to call this host merge now. And what we're going to do is... Oh, how do I want to handle this? Let me put a note here. This is... This is not even a list of tasks. What is this crap here? That is absolutely incorrect. I basically copied this from something else, and host merge should definitely not be called that. Hang on. Where's our host type right here? So this should be a dictionary of strings to hosts. So it can be a dictionary of strings to host or a host. There we go. Let's update the definition here. This is absolutely incorrect. There we go. And no, go back. Dang. I'm gonna docstring this too, because I didn't do that for. Let's see. I can't type. Oh, I gotta sit up too. I've been sitting down so much, and when I am doing reporting late at night, I get super tired, and the muscles start getting tight, and I start doing like this dowager Mr. Burns sitting like that. So I gotta sit up straight. Okay. So this is our reducer function for the host table. Let's see. New value can be host or host dictionary. I mean, I know I could look at this, but it's just easier to put it here. Let's see. Let's see. Dictionary merge will use new values over old. Host merge will be a full replace. There we go. And we'll kind of just mark down this a wee bit. Be host. Excellent. There we go. All right. So this is for merging our dictionaries in here. So we're going to do a check real fast. We're going to say if is instance. No, that is not correct. So if it is an instance of a host object, nope, this would be new. What am I doing here? There we go. I got the syntax all kinds of jacked up. Hold on, how did I do that? There we go. That's how you're supposed to do it. I'm an idiot. I apologize. Smooth brain taking over. So if new is an instance of a host in here, just like that. There we go. That's better. All right. Then what we're going to do is we're going to do some stuff. And then we're just going to make the other case. It's going to be the other one right here. So this is going to be our return. All right. So if it's a dictionary, that works out perfect. We're going to say that's going to be merge dictionary. And then this one right here, if that's the case, we got to figure out how we want to do this if it's just a host value. So what do we have that's unique to our host ones? Let's see, where's our host definition? It says ports, where is it? There it is. Oh, good. Oh, well, we didn't add that. That's okay. We can actually go add that into this. So what we'll do is we'll create another similar one that's a host ID. That's going to break some stuff. But there are worse things in the world. So what we're going to do is we're going to give this an ID value as well. And it actually doesn't need to be an annotated type, but that's okay. There you go. The host immutable tracking ID, it will never change. So if you're wondering why this is in like this, it's because if we decide to use something like, we can actually send this as required output to the language model, and these annotations will be sent with it. That's why we're doing this here. Hold on, my timer just went off to go put some more time on the try hack me box. There we go. Hold on, I broke my own rule. There used to be a visual bug where you would hit this and it'd say, yeah, everything's cool and you got extra time on your try hack me box. But you actually have to F5 this to get it to come back properly. Okay. Just as a validation, because that's bit me in the butt in the past. All right, let's see here. Yeah, so we've got this. Okay, so now we'll have an ID value where we can actually go through and we can check these things. So what we'll do is we'll say new ID, which that'll be a string, and we're going to take that out of new. And we'll just get the ID value from that. And then we'll do the same thing right here. We'll say, actually, that's fine. We just need to break out the new one right there. So what we're going to do is we want to get the key value pairs of this. So we'll do for K and V in enumerate, because enumerate should, I think, give us a key and a value pair. Actually, I want to double check that real quick. Let me see. Python loop over. Actually, hang on. Am I making this too complicated? I think I am. We have the IP address right there. Yeah, I'm making this. Okay, I want to leave the ID value in here just for future potentiality, because that's always helpful. But let's go look at this IP address down here. Because we already have the IP address for it, and that's kind of how we're tracking everything right now. Did we add a host name to that? Hold on, let me see. Yeah, so we have host name and we have IP address. So that's actually perfect. We don't have to do this by new ID. I thank you, Past Blaise. You made this actually really easy. So what we can do is, if it's a new host, then we're going to say what we're going to do is we're going to come over to current. We'll say output is going to equal current, and then we're going to say, because I don't want to try and accidentally screw anything up. So then we'll say the output and, oh, what is this? How do I want to do this? I'm trying to remember. I'm drawing a blank. Yes, okay, I know what I want to do. So what we're going to do is, since this is an instance of an individual host, we're going to say, stop scrolling. Stop it. Stop it, you. Stop it. We're going to get the new ones. What is this? IP address. Yeah. So we're going to get the new IP address, right? Meow. And then what we're going to do is we're going to say that is going to be... Yes, so what this will do is this will reference the new IP address, use that as a key in current right here. Yes, that'll work. So we're specifying an output variable. That's basically going to be a copy of current. We're going to modify this. We're going to say, hey, go find the entry with a matching key of the IP address of the host. And then wherever that host is, that particular entry, that output key is now going to be equal to new, just like that. Boop. Excellent. And then all we have to do is just return output, just like so. Easy peasy lemon squeezy. So we double check this real quick. So we have our new, we have our current. We set the output to our current, meaning if we don't see this host in here, oh. You see the problem here, though? I just realized something. If we return a host that doesn't exist, that's going to be a problem. Hey, Kaiju. Happy Saturday and Happy New Year, man. I got about 5 or 6 more exercises, then I'll wrap up this year's Advent of Cyber. Nice. Nice. Very, very cool. I've never done the Advent of Cyber. That kind of became a thing after I was already in information security. I was already working in the offensive side of the house. And so, if I was still working on Blue Team, I probably would be doing it because it would help me scratch that itch. But honestly, I do it so much. I was like, there's other things I could be working on and doing. All right, let me think about this. It's pretty much beginner level things with some complex bonus challenges. Gotcha. I mean, even the beginner level stuff, though, something that might be beginner level would be, can be tricky if it's in a particular, like if it's using a particular framework or tool or program that you're just not familiar with. All right, let's see here. So we've got this running. Yeah, this should be good. I am going to change this to an elif, though. Actually, no, this is fine. We'll leave this as an else. That's going to merge the dictionary into its place. So now our output here, we're going to do this. But we need to check something real quick. So let's do this. We're going to say if, or... Yeah, let's go bust this out real quick. Let's take this out. And we're going to just call this new IP. We're going to make this one here. And we're going to say if new IP in. What is this? I think it's current.keys. Yeah, I think that should work right there. Then Say this right here, new IP. And then if it's not in there, then what we're going to do wait, actually, I don't think we have to do this. Because let's think about it. We have two options here. Let me back this up. Back that thing up. Back it up. So here's what we had, right? We made a copy of the current object being sent in, right? We have our output. Oh, you know what I just remembered? I forgot. What we have to do is... Damn it. All right, we got to go clean this up a bit. Because if we do this, and then we make changes to output task, we're actually referencing an object, so it's still being passed by memory. So we have to go copy. We have to do a copy on that. We need to go do a shallow copy of it. Damn it. Okay, that's fine. We can do this. We can do this. Just got to remember you have to copy the variable so it's in a different memory location, so we're not accidentally updating it by reference. So, I like that event cyber. It was really enjoyable. Yeah, cute. Something that you miss on first blush can take forever to notice. Oh, dude. And I totally did, because I completely... It makes sense in retrospect, but from what I had gone through and read in the LangGraph documentation, it didn't seem like it should be doing this. Like, okay, fine. Fine, I get it. But yeah, this actually should work, because what's going to happen? If we already have a key there, we're going to update it with the new information for that key. If we don't, we're going to add a new key with the new object. So this will handle updating and unknown ones at the same time. So we're good. We're good. Okay. So host merge should work properly now. So this needs to change though. Ah, crap. How did I do that? I think it was copy.copy for a shallow copy. Let's see. We did this in the recon agent. At least I'm pretty sure I did. Where is it? Yeah, here it is. So we do a copy of that. Okay. So yes, copy.copy. I'm going to bring in copy from there. Okay. This one is fine because this is basically a read-only message. We have no problem with this. This will be good right here. But I do need to change this. We have to make sure to copy that. So copy.copy. And this will do what's called a shallow copy of it. So if there's stuff nested underneath this for these tasks. So for example, this is referencing a task object. So if we come up here and look at the task object. Go away. Task answer. Are we even using that? Oh, I guess we are. I should probably go switch that to Pydantic. But you know what? It's fine. This is fine. Here we go. Here's our task object, right? So this is string, bool, literal, string, dictionary, string, thing. So the only one of these that's this output here, these could be objects. Ooh. Ooh. Yeah, okay, so if you're wondering what I'm thinking about here, it has to come back to this same problem, right? So if we define a new task, and we're saying, by the way, it's this particular one in the task array, it's still referencing it by reference in here. Well, the same thing happens if we come over here and we've got an object, or yeah, let's just say we've got an object in here, right? And let's say it's got a K, our key A, right? And this is just referencing a string. And then we've got another one over here. And let's say this is referencing an integer, right? And then let's say we've got another one here where it's referencing an object, right? So we'll say, yeah, we'll just say object. So if we make a shallow copy of this, what we're going to get is we're going to get a copy of A. we're going to get a copy of B, but I think we're not going to get a copy of C. I believe what we're actually still going to get is a memory reference to it here. I think that one will still be a memory reference. I'm still going to stick with the shallow copy for now. I think for some of these, though, we're probably going to have to... Ooh. I think we're probably going to have to switch to a deep copy. But I'm going to stick with shallow for now. We're going to see what happens. And we'll be able to tell because we're going to make changes to this, right? So if we already see like the output appended to the input of the node, right? Because we got to remember in the trace, what is this thing here? Oh, I was searching for something here. So if we look at the input, right? And we already see like, hey, by the way, this input already has stuff done to it based on what we already just did. And it shouldn't have it because it hasn't hit the output for it yet for the recon agent. So for example, here, let's look at the messages, right? So that's how for the input, we don't really have a whole lot in here. We don't have any messages because we just hit it, right? Oh, actually, I tell you what, we got 2 messages right here. So if I saw an abnormally high number of messages because we were writing to it and they shouldn't have been written until further down in the code, we'd know that, okay, we were indirectly referencing the state table by memory address. And that's what would be messing it up. So that's an example of it. We would see the output listed in the input section down here. That's our dead giveaway to it. Let's see. So what else do we have? We had output task, output messages, which output messages just starts as an empty array anyway. Task, output task. This one was a copy. Okay. So that one should be good. This is the one we actually got to check out here. Yeah, so like this one needs to be a copy. So we want that to be there. And same thing with this for this host object. So we want to copy this host object because we can directly reference that sub object through that nested structure. I can't put a dot in there. There we go. Copy. And so we could change it indirectly by reference every time we mess with this object or this variable. We can go through and we can jack it up. In fact, let's go ahead and define this. This should be a host right here. Oh, we already did. It's already defined up there. Thank you, past me. All right, did I put the reducer in here? Yeah, host merge. Task list merge. Okay. So what these reducer functions do is every time we return something like this host data, what it's going to do is it's going to look at the data that comes in. It's actually going to pass a current copy and a new copy over to this function. And then whatever it returns is actually what's going to end up in the state table. So now that we're defining these reducer functions, we have a lot more fine-grained control rather than just blowing the entire thing out of the water. Let me double check this real quick. So if it's an instance of a host, it does this. Else, it does a dictionary merge. I think I want to do one more thing in here, actually. I do, just for the sake of stuff in here. We're going to do this. We're going to say... Basically, I'm trying to validate this structure right here. So if it's a dictionary, what do you think about this? Yeah, I think that's over-engineering. I was thinking, what happens if something that's not a proper formatted section in here happens? I didn't want a node to accidentally blow it away, but you know what? I think it's actually fine. Let's just back that out. We'll just leave this as an else right here. Because the other option is if it matched all those criteria, then they'll say, oh, well, what do we do now if it doesn't perfectly match it? Then we just return the current and we threw away whatever we've sent back to it. I think that'll be fine. If it becomes an issue later, we'll fix it. All right, let's clear this up. All right, I think this one should be good. So output task becomes... Yep, so we already defined our output task, right? Chmear. Just like that. So I think this one may be done. The validator, I think, is good. Oh, wait, we needed to return hosts from here, didn't we? Yeah, we do. So that's because that's what set us off on going and fixing the other thing. So from host, we want to return output host, just like that. There we go. Now we're going to get the main ones back that we need. Now the cool thing about this is, right, output host, if we come back up here, this is a single instance of a host object. So rather than having to go and make a change into one small section, then return the entire host table back to it, we could just make that one tiny modification. So it's going to make the tracing a lot simpler because we'll have less to drill down into whenever all this flood of data comes back. All right, did I update the doc string? I did. All right, cool. So that one should be good. Excellent. I think that actually fixed this one up perfectly. Nice, nice. I'm going to get rid of all this crap. All this, go away now. I think even this part I want to get rid of. Yeah, in fact, I'm going to just nuke this out right here. Nah, I'm going to leave it in, but I'm just going to disable it for now. Because this is not meant to be used as a modular component. Actually, I'm going to delete it out. Goodbye. You're going away. This is not meant to be used as a standalone component. It's meant to be used as part of this workflow in here. It's got very well-defined data structures that we're going to be using. All right, can turn that off. What about this one? That one should be good also. All right, I think that actually works out pretty well. Did I docstring all of these? Let me go double check. So recon agent has one. And then recon router does not, but the router, it just tells us where we're going to go in the next one. Let's see, output formatter has one and validator has one. Okay. Awesome. I think we're good. So let's go run this again. In fact, we can actually kind of do this right here. So if we look at recon, we come over to what's our input state, and we come down to change this to raw right here. Ooh, actually, I just realized something. There may be something else we need to do. In fact, I know there's one other thing we're going to need to do here, which is for hosts right here. I need to double check the usages for this. Let me see. So here's the usage of the recon agent. I know you can't see it because my big old fat head's in the way. But what I'm looking at is where is everywhere that this data structure is referenced. And I'm just trying to double check it. So I mean, imports we don't have to worry about. This is from recon agent. We just set those up. That is totally fine. And then for host updates though, we might want to go double check. Host update.py. Yeah, this is one I think we do need to double check. Oh no. Damn. This is also doing the exact same thing. See how we're modifying the state table? But this is an object. It's going to be passed by reference. When we modify it, this is going to be doing the exact same thing. Oh.
Incoming transmission from Moreno Gumby. Are you breaking stuff again?
Dude, I'm breaking stuff so much. Breaking all the things in here. Because now I'm realizing some of the helper functions, like for host updating and whatnot, this is doing the exact same thing. So like, for example, our stub host here, we need to add in the function to, or we need to add in something additional to this. Let me think. So we have IP address. I'm just double checking the fields here because there's actually a missing field in here. And I think that's what this error is. Yeah, ID is undone. Damn it. All right. So we need to define what the ID is going to be. And like, there we go. So there's the ID. The ID is going to be a random thing here. All right, fine. Yes, import that. No. Actually, hold on. Where did I import that from in tasking? Double check. That's from random.random. I want to make sure I'm using the exact same one to try and save a little bit of. Yeah. And then import string. There we go. So that should be good right there. Let me double check that real quick. String. Yeah, just the string module. All right, should be good right there. So now, all right, I knew there was one in here where we were getting the stub host. Definitely needed that. That's fine. All right, so for host right here, this is not what we want to do. Where else is host referenced in here? Just right there. All right, so let's double check this real quick. Does host data ever get written to? Does not. Does tool output? It doesn't. All right, here's what I'm going to do though, is we're going to change this. We're going to say, I'm going to change this to input state. And then what we're going to do is, we're just going to do a little bit of sleight of hand. State is going to equal a copy of input state. Like that. And then we're going to import the copy library. There we go. Now, why is it throwing an error here? Oh, I think I need to tell it what the shape of this is, that it is a stinger state. There we go. It didn't like the shape of it, or at least it would have worked, but the type checking in the IDE was like, hey, this isn't matching because it didn't quite know what this was, because the copy function is going to return whatever. It's not going to return a particular type. So we had to tell it, hey, by the way, the shape of this is that it's a stinger state object. Now it all looks good. So now it doesn't matter if we make any changes to the state table. So what we want to do is we want to return just this. Let's see. I'm actually going to define this down. Because this should only be one particular host, right? We're not looping over anything. So we're going to follow that same naming convention here. So we'll have output host. And this is going to be a host type. And or a none. And we'll start off as a none right here. And then we're going to take all of this, right? And then we're going to say, nope. Our output host is now going to equal this guy. No, not like that. Actually, that technically does work. But I don't know what the assignment order is for this, so. It's really something here it doesn't like. There we go. And now output host is what we're actually going to return. Just like that. This right here is okay because as we return this one particular message, we haven't made any other changes to the state table. All right. Dude, just unspaghettifying the code. That's what we're doing here. All right, so we fixed the stub generator. We fixed the output on this one. Okay. I think we're good there. Anything else? Let me think about this. I think that'll do it. Hosts are still empty right here, which is fine. So now what we can do is actually we can kick this one off here by dropping in that entire object right there. Yeah, continue. What, you didn't like that? Okay, fine. Start at recon agent then. Jeez. No, that's not going to work. Damn it. I hope I didn't just crash it. No, how do I stop it? Stop it, you. New thread. There we go. Oh, is it throwing an error? Does it like instant type checks? Oh, it doesn't like that. Oh, no, that's going to suck. So what is this error that we're getting here? It's trying to return something and it's failing out. So we got is typed dict does not support instance and class checks. Because it's a typed dictionary. I know there's a way to. I think you could do that with the dunder variable. Hang on. Let's see. Python dunder variable to define instance type. I don't know if you can actually use with the types dictionary. So if you're not familiar with what dunders are, it's what's called the double underscore kind of magic variables that exist in Python. And they can do all sorts of cool stuff. It's actually, if you do a lot of Python, it is well worth the read to understand how they work and what they do. How do I want to do this? Dunder variable checked by is instance. Which one is it checking? So that's the built-in function returns true if the instances are direct or indirect instantiated type of class. What is it actually checking though? Instance check. Oh, we actually have to go define that. We have to, so you don't just have Dunder variables, you have Dunder methods as well. So in this case, for instance check, damn. We would have to define that on the typed dictionary, I believe. Janus Jordan, Happy New Year, man. Yip, yip, first stream of the new year. Normally just use the double underscore. Yeah. Or the init method. Yeah. So this takes in self and an instance in here. Well, we have two options. We can either say it's a typed dictionary, or we could go through and we could see. Dang. Hey, Robo, Happy New Year, brother. How do I want to do this? I'm trying to think if I want to even try this route. I mean, it'd probably be helpful. Can we not define an is instance on this? So person, this one's a person metadata. Oh, I think we have to actually define this as a class reference in there. Almost done with painkillers, but I'm going to be in the neck brace for another 4 to 5 weeks. Oof. Oof. I'm glad it's getting better, man. Dude, I had to take so many pain meds when I blew that disc out of my back. And that was just about a year ago. It was literally like the first or second week of January I did that. So I've been doing a lot better. I need to keep stretching though. So one of the problems is a lot of the muscles get tight and then it pulls everything out of alignment, and then other muscles start squeezing to like try and fight it, and you're fighting your own body. It gets to be very draining. And I didn't realize that was what was happening, because I used to stand up all day. Like I stood up from, unless I was driving my car or eating lunch, I was usually standing. I had a standing desk at home, I had a standing desk at work, and I barely ever sat down. And I just started getting really beat down at work, lots of long hours, and I was just dying. So then when you start getting tired like that, all those muscles start tightening up and start squeezing, and you're literally fighting yourself to stand up. It's annoying. Hang on one sec, guys. All right, I'm back. I'm still here. I was trying to figure out why it was so freaking hot in the office. It's because the fan was turned off. All right, so I don't think it's going to allow us to find this mirror, but that's all right, because what we could do is we can change this. And what we'll do is we'll say We'll just define like that. It is. What do you expect? It's the exact same thing here, bro. That make you happy? IP address is a string, though. I don't get it. Must be a string literal. It is. It's going to point to a string. You suck. Alright, fine. Will this make you happy if we do IP address? Can't type. IP address string. Let's say you're now going to be equal to this, and then we'll just put in IP address here. There. Will that make you happy? Are you happy now? You suck. Hold on, let me back this up a bit here. So we had this be type post here. It had no problem with it. It changed on this. Oh, we changed that to a list. Okay, so this was modified. This was added. I think we're okay. Hey, Trojan Mango. What's up, dude? Trojan, actually, if you want to learn more about stuff like that, for legit reasons, like if you're... Because there's a lot of guys that on my team that have gone through this. They like it. I've been meaning to go through it. But there's actually a really cool learning resource called the Maldev Academy. Not malware dev. And this is a really cool one. They've got the malware developer course is actually the main one in here that they've got. And it's pretty legit. I like it. So here, I'll drop a link to it for you. The main thing I say is make sure you have a solid understanding of C before you hop into it. So understanding at least the syntax so you can work your way through it. But yeah, a lot of this is done in C. I don't think they do it in C++ at all. I think it's all pretty much in C lang. All right, let me see here. So why is it all of a sudden complaining about this now? This thing's so dumb. Yeah, you're fine. Stinger state is just fine. Stinger state is based off of a typed dict. You're fine. So for some reason, this reducer function here, it doesn't like. Why is it throwing a fit about this? So right here it says the type dictionary key must be a string literal. Expected ID, IP address, host name, ports, initial access exploit, or verdicts. Okay, we're actually passing in the IP address. We're just referencing it from a different spot. You're fine. You're fine, bro. What are the other rules? Okay, so the first rule is don't hack the stream. That's why I'm doing my work. The second rule is everybody in chat's a fed. Or sorry, take that back. That's rule number 3. Rule number 2 is don't talk about anything illegal in the chat. Because rule number 3 is everybody in chat is a fed. See rule number 2. And the fourth one is just be excellent to each other. I understand the syntax. That's when you have to pay the government extra for beer and cigarettes. Right? The thing I always thought about with that, Ken, was there's a tax on something to disincentivize it, right? You have an extra tax on gas because you're driving too much, you're polluting the environment. Okay. There's a tax on, beer. There's a tax on smoking. Okay. Why is there an income tax then? Rule 76, no excuses, just play like a champion. I'm trying, man. I'm trying, but you all know that I'm a scrub tier developer. Suppress for this statement because I don't want to go through and fix it. That is just fine up here. What is this one? Oh, that should not have even been there. Oh, that's right. We changed that to host merge. That's totally fine. Okay. So the problem was, it said we didn't know how to find out if this was an instance of this, and that's totally cool. So that's what we'll do there. Let me see if this hot loaded in. All right, it did. Let's see if we can run this again. The heck is this? Typing error. Typedict cannot be used with is instance. You freaking suck. All right. How can we use this then? Let's do a little Python and play around it here. Not what I wanted. Here we go. All right, so damn it, screwed that up. Smooth brain attacks again. All right, let's import type dictionary. Let's define a test class request. So test class, and this is going to be a typed dictionary, and then we're going to have an A field. How did I define this? Yeah. A field, which is going to be a string, and then we'll have a B field, which is going to be an integer, just like that. Oh, wait, I don't need the comma there. There we go. So we have a class defined here. So we have nothing on the, let's see, test class type dictionary name type dict. So let's try something here. Let's do it. Let's make a new one here. So we'll say, let's just say foo is going to equal a test type, and we're going to say, I think it's A is going to be equal to kitty. Wait, no, this doesn't need, forgot. There we go. A is going to be equal to kitty, and B is going to be equal to 69. Nice. So now, what does the shape of foo look like in here? We have a length, we have protected attributes, which is none. So it just shows up as a dictionary in there. Okay. Well, types dictionary, you make me sad. You make me very sad. We're not all fed, some of us are NSA. Nice. Supposedly the income tax was to fund the federal government, but we know that's not true. It's not. And you want to know how you know it's true? Let's see. Federal deficit. I believe this is it. Yeah, here we go. Oh my god. Fucking spam malvertisers. There we go. So here's the debt clock, right? There's economists that sit here and basically watch stuff like this all the time, right? They're just sitting here and they just let it run and run and run. And there was one day the economist was watching this and he said it actually went down. It never goes down. And it went down by like a perceptible amount. Not like this one right here where it's like it's down $14, right? 14.2 billion. It went down by a perceptible amount for one day. And then he realized that what had happened was that was tax day. And it just blew right past it, kept going up. So the federal government's spending so much money, it blows past anything the income tax is supposed to do. So why even have the income tax? Well, just like you said, for the sin tax is to discourage income. My personal opinion is because they want you dependent. They don't want you to be able to be self-sufficient. $38.6 trillion in debt, right? Yeah, it's redonkulous. All right, so if this is the case then, since this is showing up as a particular, basically just a dictionary type in here, then what we'll do is we're going to just check and see if it's a... Oh, this is going to suck. Dang. So if that's working as a type stick and we can't do a test against it to see if it is there. Let's see. Type checking against height. Actually, let me do, yeah. So we could use something like type guard for this. Wait, are you saying that everything driving towards the rental economy and the big push of you don't own anything, they want us completely dependent? That's exactly it. That is exactly it. So, yeah, you will own nothing and be happy. So that's why everybody's going back to physical media. There's a huge push for what I was just reading about using physical media. In fact, I got really, utterly pissed off doing Christmas shopping because I specifically find for the Nintendo Switch, and I've already told this story, but Agent Zero is deathly afraid of system updates now because of the crap that Nintendo pulled, where now you've got the virtual cards, right? It used to be we had purchased a copy of Mario Kart, we had a Switch at my house, and then my parents bought a Nintendo Switch for their house, for the kids to play on. And they're both logged into the same account. So, didn't matter where he was, he could play Mario Kart. It was great. Then they do the virtual game card BS. And you can't transfer the virtual game card from one network to another. They have to be on the same fucking Wi-Fi. And ever since then, Agent Zero now is deathly afraid of system updates. So, congratulations, Nintendo. You've just preconditioned an entire generation to ignore the one thing every security person has been saying, which is update and patch your crap. Anyway, I bought games for the kids for Christmas, and one of them was a little Mario game, and I specifically bought physical game cartridges. And they know they have to take care of this Switch because I absolutely told them under no certain circumstances will I ever buy a Switch 2. I said, kids, they're not getting anything else. The Switch 2 is a non-starter. I will never buy one. So they go through, and to help facilitate that, I bought physical cartridges for them for their Switch. And one of them came in, and it had two versions listed on Amazon. One was digital code, and one was physical. Well, the physical one was just one that came in and was a little redeem code for it, but it was a physical box. I'm like, you have to be freaking, I was livid. I lit them up in the Amazon reviews. I wanted a physical game cartridge that could not be taken away and could not be moved offline. I was like, hey, Masterism, what's up, dude? So BlackRock, Rockefeller, and whoever else years ago sat around and came to the conclusion that it would be beneficial to them or the government to change the school system to dumb down the population. Because a dumb population is a government-dependent population, and it's been working decently. You're not wrong. And if you actually look at the history of public schooling, it was never about boosting education. It was about teaching kids how to be good factory workers, how to sit there and work on essentially mind-numbing tasks repeatedly over and over and over again and not complain it and don't question authority. That was part of the reason why my wife and I homeschool, because I do want them to question authority. It's baked into me. That's why I'm in the field that I'm in doing offensive security. And also, I want them to be able to think for themselves and come to conclusions based on logic and reason, not just because someone else said something. Yeah. The current incarnation of actually just mass general public education was never about improving educational outcomes. And if it really was, they wouldn't be letting kids pass that were blatantly failing courses. No Child Left Behind became just pass them anyway. So what did that do? Devalued the prospect of having a high school diploma. So it used to be you had a high school diploma that was actually worth something. Now it's like, oh, well, everybody's got a high school diploma because they won't fail anybody. So the high school diploma essentially turned into a participation ribbon. Dude, you're going to get me off on a tangent. Let's see. So according to the little AI overview here, static type checking with MyPy and a runtime validation with TypeGuard can provide mechanisms for checking type dictionaries, but they lack an instance support. How do I want to do this then? What is MyPy?
Incoming transmission from Moreno Gumby. Let it all out, man. We love to see it.
No, you don't want to let it all out. You don't want to. I try to keep a nice, stable, even keel on it. But there's some stuff where it's like you start researching the history of things and like how they actually evolved. Hey, Drewski. And that actually even goes like I'm talking about like a lot of things. So even in the studying I've done about biology, even there's a lot of times where like, oh well, let's take the appendix for example. What happened? Everybody was taught that the appendix was a vestigial organ that didn't exist for any good purpose, and it just hung out there in the body. Well, no, you start looking back and you start realizing that our bodies were optimized over millennia, multiple millennia, millions of years. The body's been evolving to try to help you survive a very, very harsh reality that we don't live in anymore. There's nothing vestigial in your body. It is optimized for something. And sure enough, a couple weeks ago, I was reading a report that says, hey, by the way, we think the appendix actually might be a safe haven for good bacteria in your body in case there's an influx of bad bacteria because you ate something that you weren't supposed to. Which makes sense, because if you start thinking about the stomach acid composition of the human stomach, it is so high. It is super acidic. It's way, way up there. And why? Because for a long time, humans weren't really that great until we developed tools at killing anything. So prehistoric humans were a lot of times carrion. They were feeding on dead carcasses that were left behind by other actual apex predators that could go kill something. All right, rant over, I promise. The whole point of that was to say that there's usually a root cause for something. And a lot of times when I look at like what's going on with the body, evolutionary biology is the way to look at it. That's going to get you there like 99% of the time. Anyway, I'm not a doctor. I'm just some idiot on the internet. I don't know how to actually use MyPy. Let me look at this again. Optional static type checker for Python that aims to combine the benefits of dynamic typing and static typing. Combines the expressive power and convenience. I mean, this is pretty much, I think this was already rolled into. Yeah, this is what we've already got in here. Sorry, I just realized while I was ranting, I missed a bunch of chats. Let me catch up on those. The problem with socialism is you eventually run out of other people's money. True. It's very true. Let's see. So my BS from OU, who has totally shit the bed in their recent BS, now I just have to refer to it as my MS instead. Yeah, Microsoft is a BS. Let's see. It was, well, okay, Gumby, yes, it was also used to digest raw meats back in the day. True. But at the same time, if you were hungry and you were starving, are you just going to pass up a potential carcass that something's left behind? Probably not. Yeah. I'm still not going to go eat raw meat, though, Gumby. I still have my appendix, but now I also have a table of contents that was removed. Damn it, Ken. Damn it, Ken. You read any books or papers on surgery or finance? Yeah. Yeah, I did a lot of study of finance back in the day. I used to actively trade stock options and futures, and yeah, so I did a lot of active work like that. Not like MBA style finance, but like actual like stock market type finance. I didn't know that, Gumby. I didn't know you were a surgery nurse. Appendix was known to be beneficial for decades, so don't remove it unless absolutely needed. Yeah. The only time I know of, Gumby, that they actually tell you to like, hey, go, you have to get your appendix removed, is there's a research station in, I want to say, Antarctica, and it is so remote and so far out there. They actually have that as a requirement if you're going to go be stationed at this research station, because if you have a problem with your appendix, they assume you're going to die, because let's face it, without particular, I think, antibiotics to help control that, or if it just pops, you're toast. So they actually do require you to get it out because you're going to this really extreme environment. Don't eat sushi? I do love sushi, though. Damn it, Ken, how'd you know my nickname? That's right. Whoever designed humans did an impressive job. I firmly believe that. So I make it no secret on the stream that I am like hardcore militant Catholic, right? That's me, that's what I do. And I never had the disillusion that everybody's like, oh, you have to be science or religion. I was like, that's not true. I always viewed it that God wrote the universe in the language of science. That's a very simple understanding, right? If we're going to have a coding language and we are developing coding languages and we have a piece of the divine spark, why couldn't we just have the same thing, right? I said monkey, didn't I?
Incoming transmission from Moreno Gumby. That was monkey. That was the surgical nurse Blaise.
Sorry, I was reading it, but I thought I said monkey. Yes. But anyway, actually, I'll tell you what. One of the things that actually really convinced me of the idea of not go too far off into the religion path, but of humanity's divine spark was actually mathematics. Because if you think about it, our mathematics only exists as long as humans exist. If a giant meteor or black hole or whatever completely obliterated the Earth and every piece of human knowledge was wiped from the universe, our mathematical constructs would cease to exist. The mathematical universe that we have constructed with the ideas and the various axioms and theorems only exists insofar as humanity exists. And so that started getting me thinking about it. I was like, dude, we've created something that only exists because we exist. I was like, I thought that was pretty cool. All right, I don't think MyPy is going to actually help here. Because MyPy is basically what we're already doing with the type checking built into Python 3. I don't think this is what we need here. We could either go build ourselves a function, or we could try something else. Oh, what was the other one here? TypeGuard. Let me look at TypeGuard. Library that provide runtime checks for functions defined with PEP 484 arguments and return types. So check type is like isInstance, but supports arbitrary type annotations within certain limits, and can be used with cast replacement, but with actual checking of the value. Huh. Interesting. TypeGuard examples. Let me look at this before I go try and throw another library into this cacophony of libraries we've already got. Let's see. So the most straightforward way to do type checking with TypeGuard is with the check type, so it can be used as a beefed up version of isInstance. Also supports checking against annotations in the typing module. Oh, really? Because I believe that is where the annotations actually comes from. Yeah, typing annotation. Nice. Very nice. Very nice. So, let's see how this works. So from typing, we import list and typed dictionary. Have I been using the wrong typed dict this whole time? Man, I really hope not. Is this using the typing dictionary? Well, we're not using typed dict over here. What about an output formatter? So we're using it over here? No, we're not. I don't know why that's in there. No, go away. Interesting. Google search simulator game is crazy. Yeah. Oh, I miss when Google search was actually nice. Let me see here. What is this one? Let's skip this on. Two Bob's got a song called Azure. Nice. Not the Azure I'm thinking of. I think that's probably referencing the color, but I'm thinking Microsoft Cloud. Let me double check something real quick. Let's see. LangGraph typed dict. Where are they? I wanted to see where they're actually. I wanted to have them actually. Yeah, so it could be a type dict or a pedantic model. So they're using the one from typing extensions. That's why I was using the one from typing extensions. However, is there a difference between these two? Let me see. I don't know if I'm logged into log. I don't know. Just won't log into it. Let's see. Let's see. What is the difference between type dict from typing. What was the name of it? Typing versus typing underscore extensions. Yeah, that one. There we go. So type dict from the typing module is part of Python's standard library starting from version 3.8. Typing extensions package provides a backported and enhanced version of type dict that includes bug fixes and improvements not present in the standard typing module. Really? Ensures consistent behavior across different Python versions, including proper handling of total equals false, support for multiple inheritances, with typing generic consistent from orgbase. Additionally, typing extensions is required for Python version below 3.12. So maybe that's why they're using typing extensions instead of just the typing module. You got a burning question? Just ask away, Drewski. Don't ask to ask. Just ask, bro. Now, how are they doing this with Pydantic? Let me see here. So you can use Pydantic, but there's limitations to it. So the output of the graph will not be an instance of a Pydantic model. Runtime validations only occur on inputs to the first node in the graph, not in subsequent nodes. Well, that's a rip. Pydantic's recursive validation can be slow. For performance-sensitive applications, you want to consider using a data class instead. I've got to read up more on Pydantic. I'm only using it at a very surface level in this project. Okay, I don't think I want to make that leap where I go retype all of the state table and everything into Pydantic models. Still got type dict. I just need to know if it's going to break anything if I switch it from typing extensions to typing. Ask a follow-up question. Will it make a difference when using typing instead of typing extensions? I misspelled that. Extensions or type dict in LangGraph. We'll see what their little AI says. I never tried this. New grads clear 300k at Fangs. Oof. Yeah, I don't clear 300k, that's for damn sure. Although I like my work a lot better. Yeah, that's a really good point though, Monkey, because total salary compensation is actually a really crap way to look at it. So when I took my current role, I actually took about a 30%, 35% pay cut. However, once I factored in the benefits package, it actually ended up only becoming about a 10% difference in total take home. So and also my cost of living obviously didn't change. But if you have a lot of factors to think about. If you're thinking about moving somewhere for a job, you got to look at what is your raw compensation, what's your total compensation, things like benefits to medical, dental, 401k, all that jazz. But then you've got to adjust that for cost of living, because if you're moving from somewhere like, Dallas has a pretty low cost of living, especially compared to somewhere like the Bay Area, Los Angeles, Chicago, New York, any of those areas, you're talking about like a massive increase in your cost of living. Rent's more expensive, food's more expensive, everything's pretty much more expensive. So yeah, it might look really sexy to like, oh look, I'm gonna making 300K over working in the Bay Area, and you realize that that cost of living translates to like maybe like 140 in Dallas. Let's go look at that. Hold on. I'm gonna close that. There's a really awesome website that I like. It's the Bankrate Cost of Living Calculator. So bankrate.com, they have a cost of living calculator, and you can basically put in where you live. So let's say I live in Dallas, right? And let's say I needed to move to, let's see, San Francisco. And my current income is, let's say for a nice round number, let's say I make 100K a year. I need to make 63% more to go to that. So let's swap those around. So if I'm in San Francisco and I move to Dallas and my current compensation is, let's say, 300K a year, I'd have to make 180 right here. Now, I've had jobs where I made this. So yeah, it might sound really sexy that this is what you were making. And, or it might sound really awesome that you're making 300K, but you're living in the Bay Area. I was like, well, cool. I'm only making 180. Doesn't sound as cool, but I live in Dallas where the cost of living is a lot lower. Oh, sanity compensation's a big deal too, Bobby. Yeah. So the reason why I took the pay cut to go from my last company to my current company is because I gained a lot of psychic income from that, right? I like the people I work with. I like the work I'm doing better, even though it's still offensive security. It's just, it's run much more efficiently. And I'm working with just a higher class of client. So that makes me a lot happier. So yeah, there's a lot of psychic income that came with it. And there's a lot of encouragement to grow. Whereas at my last company, it was just kind of whatevs. We're just going to keep doing what we're doing. We're never going to adapt. We're never going to change. We're never going to improve. It was a beatdown. All right, so Drewski said, I'm working through doing wrestling exercises. I don't understand the difference between vectors and something like a list or an array. So I'd also understand the difference between slices and indexing in a list. All right, hang on. I don't even know what Rust vectors are. So the first question was difference between a vectors and versus list or array. So one thing they sometimes will do, Drewski, is they'll give something a different name on purpose because they don't want to carry over any mental baggage or associations that you've got from something else. Golang does this. I forget what the data types are, but they purposefully named something different, even though it acted like what you would consider to be, I want to say it was an object, but they didn't want to call it an object because people have predefined notions about what an object is. So they purposely gave it a different name so that you would think about it differently in that mental space. All right, so hold on. I'm reading up on this, so hopefully I can explain it to you. Let me see. So in Rust, vectors and arrays are both fundamental data structures for storing collections of elements, but they serve different purposes and distinct characteristics. Arrays are fixed size collections whose size is determined at compile time. Okay, that's a big deal. Good remember, because Rust is a strongly typed language. So your array is never going to grow unless maybe you go like cast a new array and you say, this is going to be the size of it. Then we go to it. But even I'm not sure you could do that. You could do it in something like C. I don't know how this would necessarily work. And basically this makes the stack allocated in offerings faster due to the absence of heap overhead. So you don't have to worry about allocating memory to the stack and the heap. It's just bam, right on the stack. Let's see. Vectors are dynamic arrays that can grow or shrink, which means they're going to be stored on the heap. Yeah. So that's the main difference there is one is a fixed size Drewski, which is your vectors. Oh, sorry. I take it back. Your arrays. Arrays are your fixed size. Think of it like you can have 100 of them, and let's say they're containers for something, right? But they're always going to be the exact same container. And if you fill up one, you've got to go make a new one to start filling it up. So arrays are fixed size containers versus a vector, which can be like basically dynamic array. Think of it like you're putting water into a balloon, right? The balloon can swell and shrink to hold the different volumes of waters. let's see. The other thing you asked about was difference between slices and indices. So typically a slice is when you're saying, I want to take a section from like one to another. Let me see. Let me see what they say about it, because I'm not very familiar with Rust. I just get the idea. Slice versus index. Okay, so they're using that term in the way that I'm familiar with, which is an index refers to a specific position within a data structure. So basically saying, go to the beginning of this data structure and go offset by X amount, and then take the data at that portion right there. Yeah, and pretty much they're doing exactly what I thought, but I always want to double check whenever I'm dealing with a language I'm not familiar with. Slice is a reference to a contiguous sequence of elements within a collection. Usually, so you're going to have a start and an end, or you're going to have a start and an iterator that's going to say, hey, you're going to start here and you're going to iterate X number of times and then take that continuous chunk back out. So yeah, a slice is, think of it like a puzzle, like you're putting together a jigsaw puzzle, right? And basically the jigsaw pieces form more or less a grid, right? So an index would be one individual puzzle piece. You stick it with the pen, you pull it out, you have pulled out one individual puzzle piece. Whereas a slice would be like, I'm going to take every piece in this row, or I'm going to take everything from position 2 to 7, and then I'm going to take those ones out. So that's the difference between it. Slice is a continuous section of data. An index is whatever's at one position of data at that point. Yeah. And well, the reason I wanted to double check it and at least check the AI overview was to see if my understanding was correct, because like I said, I really want to like Rust. I cannot get past the syntax barrier, man. The syntax is so bad. Ugh. The syntax makes me want to just gouge my eyes out. Yeah, pretty much. That's the difference, Drewski. It's how much data you can pull out at a time. And also, it's the continuous amount of data. So if you're going to pull out one element versus a range of elements that are continuous, right? So if you needed to pull out discontinuous elements, you're going to use a multitude of indices. So you're going to say, I'm going to take out 3, 7, and 11, versus a slice, which would be, I want everything between 8 and 10. Bam. And you're going to take those out. Do you think it'd be wiser to study Lippinscott, or actually should I focus on gerontology? I have no clue. I don't think I've read any of their particular works. A lot of the stuff that I've read has been more or less anecdotal, not academic. Okay, so according to this, we do want to stick with, I want to take this back out. I'm going to revert this change here. Revert. So we're going to use typing extensions because that is what LangGraph needs. We're going to leave it just like that. But I don't think that's going to preclude us from using TypeGuard in here, because they're essentially the same. One just has a little bit more robustness, which is in the typing extensions version. So let me see how they're doing this. So for typing, they import list and type dict. From TypeGuard, they import check type. So here, they're going to do a check type. They're going to load JSON and make sure it's a list of persons in here. And the person is a type dict here. So let me think about this. They're saying this is a list of persons in here. So the kicker we've got over in the state table is the host field is literally defined as a dictionary that matches a string to a host object in here. So what we might need to do is we might have to abstract this part out and make it hosts. Oh, how would I do that? I wonder if that would actually work with TypeGuard, with the type check. Let's see, type checked also has a decorator, so it's the simplest way to add type checking on a case-by-case basis. It can be used on functions directly or an entire class, in which case all the contained methods are instrumented. So the decorator instruments functions by fetching the source code, parsing it into an abstract tree, modifying it to add type checking, finally compiling a modified AST into bytecode. Interesting. All right, there has to be a better way to do this. So the reason for this is we're giving options here where you can return a single host, or you can return an entire host dictionary that matches a string to the host. So how do we want to do this? Because the problem is this is going to match a dictionary, and this is going to match a dictionary. This is always going to be the current right here. This could be a dictionary mapping to a host, or it could be a host object itself. Well, I can think of one stupid way, and that is if we look at the host definition, it has certain fields to it, like an ID, a target IP address, things like that. Let me try something here real quick. Where is... I have to go import annotated. No, this needs so much in here. We need task answers. We need a whole bunch of other crap. Here, I tell you what, let me do this. I'm going to take a copy of this. Let's do something real quick. Hang on one sec. Okay. I was making sure I wasn't going to dox anything because they can't just leave Notepad alone. They bring up all this other crap. Here's what I'm going to do. I'm going to make this a lot simpler here. We're just going to have it match types in here. So take that out. This could be a list of strings right here. Basically, we're just de-annotating these, and I'm just going to take out verdict right there. Let's take that out, and we'll take out the initial access exploit too. And I'm going to change this. This is going to be a dictionary matching a string to an integer, just for this example. Okay. You can take that out. What I wanted is just something where I could double check. I could check this and go play with it real quick. So let's pop into the Python real fast here. So let's go define this. So we're going to define a host class. Ah, damn it. It's using the uppercase list. There we go. In fact, I'm going to change that right now. I don't want to use the one from typing. I want this lowercase list. All right, so we'll make a change there. So when we have this, let's do new host is going to be a host, and what we're going to have for this is we're going to say ID equals, I don't know, AAA12. So we're going to do that, and then we'll say the IP address. I'm just going to throw some random stuff in here. This is going to be a string also. 1111. I'm not done yet, dude. Oh, I needed a comma in there. I'm an idiot. Let's see. For this part, I did need the comma. What else did I need? We need... we also need a host name. Let's do host name. That's going to equal one thing. We're going to call this local.host. And then we need one more, which is our ports. And that is a dictionary. And we're going to match... Why did I do strings for that? I don't know. What we'll do is we'll say this is going to be 445, just to have something in here. And what did I say that maps to? An integer? I know. I'm just going to put something in here as a placeholder. So we'll say SMB and then we'll say 445, just like that. All right, so there's our new host right there. So if we look at the actual host definition here in memory, which I know you can't really see because it's back here behind my big old head. So host is just a class here. How does type dictionary even work? What methods do we even have on this that we can potentially use? So let's see. All these are just dictionary types in here. Wait a second. So that gives us what the class is, but that just gives us a typed dict metadata. Not super helpful. What else do we have from our inspection here? So we have class, we have our text signature. That was useless. So there's nothing in here we can technically tell it what it is. Oh, sorry, Bobby. Let me see. Could you give a quick recap on what the issue you're encountering with the agent state is, and was the refactor of the code or something else causing the problem? So we're currently refactoring the code because what happens is... Actually, hold on, let me check something real quick. Add time. There we go. So here's what's happening, Bobby. If we look over here at what happens in our state, right, or our graph here. So what we have is we have a state object that's managing everything going on. And each node here is a Python function. That's very important to remember. It's a Python function that is passed the state table and can return changes that are going to happen to the state table. Now, out of sheer dumb luck, as a design decision to try and keep my own sanity, what I did is I was pulling out helper function, or basically helper variables, to try and make referencing data in the state table when it gets passed to that function simple, and then only modifying the state table for what we wanted to return. The problem became that once you start thinking about how Python works, whenever you pass an object to a function, it doesn't do it doesn't give you a copy of it, it gives you a memory reference. So it's differences passed by value or copy versus passed by reference. And so the way this works is, let me come back over. Yeah. Let me clear this out real quick. Yeah. Flashbang. All right. So when you pass by value in here, so you've got some function, right? And let's say you're going to pass in variable x, right? So when you pass this in, you've only got two options here. It can pass in an actual value of it. So if you pass in a variable that's like 5, or say it's an integer, then you're going to get a 5 in there. But the other option is, and this is done for all objects, is you can actually pass in the memory reference to it. So I don't know why I put an F there, a memory ref. So the memory reference in here says, okay, rather than actually getting a copy of it, let's say this actually becomes a 5, right? This will actually point to some object, and it will say, oh yeah, this is at, memory address 0x blah 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 blah. It's pointing you to a position in memory. So what happened here is when we're writing this code, when we said something like, hey, we're going to make a change to the state table and it's going to be some value in there, is now going to be equal to like foobar, because that's what the code is. It's foobarred right now. When we change this, we're not actually changing the copy from state here. What's happening is this is actually referencing the state table in memory somewhere else. So while it was technically working, it was not working well, and it made tracing the issues much more difficult. The other thing that we're doing here is when we had the annotated type, is the annotation does say, hey, this is what the type is. So let's say it's a string, right? But the second variable, where we did just have like 3 dots right here, and then we had the description, that 3 dots basically said, don't use a reducer. So the reducer here, we could actually reference another Python function that says, hey, when something's going to get updated, here's how you do it. Here's a function that says how you're going to either handle this new string or this new object or this new list of things. That's what's happening. So what I wanted to do is we defined a new reducer over here, and it was how to handle updates to the host tracker, right? So here in the state table, we have hosts, and that is all the network hosts we've discovered. So in this case, since it's a single machine CTF, it's just going to be one host. But eventually, I do want HackBot to be able to go through and work against larger networks, something like Game of Active Directory, right? So we need to be able to track multiple hosts in the environment. So this is defined as a dictionary that maps a string, which is really just the IP address, to a host object here. And so the host object looks like this. We've got an ID, IP address, host name, whatever ports there are. And then we can also store an initial access exploit and a verdict against it. So the kicker here, though, is that this host, when you reduce it down to what this type is, to its basic functionality, it is excuse me, it is a dictionary, not a typed dict. So a typed dictionary, let's see what the description here says. It's a typed namespace. At runtime, it's equivalent to a plain dictionary. So that's the kicker we're running in. So we're looking at what is the runtime checking for this. And why does this cause such a problem? Well, because our, let's see, what is this, current? This is incorrect. Current cannot be a host. It has to be this. So we start looking at this. Yeah, this should be new here. Take that back. That's why everything is all jacked up. So this reducer takes in 2 arguments, whatever our current one is and whatever our new one is. So current is going to be whatever's in the state table when it enters that function. The new one is going to be whatever we send back in the return output from the function. And so I wanted to have it to be 2 options. It could be a dictionary matching a string to a host, or just a host object right there. I think the simpler solution here is actually just to take this out right here. I think that's the simpler solution. because this is causing us all sorts of headaches. So this could even just be a dictionary with one item additional in here. Let me try something. Let's pop into the Python library here. In fact, hold on. Let's start from scratch here. I want to try something. Let me think about this. I want to define an object. So we're going to call this one object 1, and this is going to be an object with an A value. And we're going to make this 1, just like this. And then I'm going to do the same thing here, but I'm going to make this a different one, object 2. And then I'm going to make one more. We're going to make this object 3. Object 3 is going to have an A value, and it's going to have, wait, I screwed that up. It's going to have an A value of 1. A1. There we go. Actually, I'm going to make it 3. There we go. That's going to be 3. And then we're also going to have a C value in here. That's going to be, I'm going to make the C value 3 as well. So here's what I want to do. So we've got this right here where we say, hey, here's current, here's new. We're going to return that. So we're going to return an object that's going to merge these two together. So I want to see what happens when we merge object 1 and object 2. What do we get back? So we get A1, we get B2. Awesome. So this is perfect because I didn't know, it makes sense. So what this is doing is basically like, it's like a spread combination of the two in here. And so if we change this from object 1 to object 3, what's going to happen is object 3 has an A and a C, right? And so when we set this up, what should happen is we should just get back A and C. And in fact, I think we could even do this a little bit differently in here. Because the way this is working, there's not anything that says we couldn't do this. Let's do this as a 2, and then we'll spread out object 3 as well. When this all comes back, what should happen is it should take all the key value pairs from object 1, and then all the key value pairs from object 2. So we'll have an A1, A2, or an A1 and a B2. But then it's also going to add in 3. So now what it should show, if I'm thinking about this correctly, is we should see A3, B2, and C3 when this comes back. Yeah, I see what is happening here. Okay, perfect. So what this means is all of this was completely worthless. It was not really worthless. It was a good exercise, but we ultimately don't need any of this right here. In fact, there's an easy way to do this. Boop. Let me refactor this. I think it's Shift F6. Yeah. We're just going to call this host merge right there. So what this will do, oh, wait, I need to change this though. This should be, because I do want to have the typing in here. This is going to be a string to a host. I copied this from the other one and I forgot to update the typing data on it. So there we go. That's going to be a string to a host just like that. So what we're going to do is we're going to spread all the values out for the current state table, and then we're going to overwrite them with the data from the new side right here. So if there's anything that overwrites from here, that's awesome. And that includes overwriting blank spaces. So it wasn't updating the literal state from the returns and only from memory. Only from the memory address prior to the reducer functions. Yeah, so it was partially working somehow as the agent passed the returns though, but it explains why it was so consistent. It doesn't necessarily cover the inconsistencies, but what was happening is as it was executing down through the code, it was coming through here. Actually, hold on. I can give you a perfect example. Hold on. Let me open the enumeration agent. Here we go. Questing music just in time. All right. So this regex is looking for anytime we start with state expression here, because that was the function that we used, right? So see how this one is accessing the state directly? So here's what we have. We have our enumeration agent,
it takes in one variable called the state, and it's a type stinger state. When we write to this here, we're writing to the memory reference. Now you're good, Bobby. But this is the perfect example. So for example, this is in our enumeration agent. We say the state's current task is equal to blank, right? All this jazz right here. What we've done is we have replaced this with something like this. Should be right around line 35 because recon and this is the exploit agent. Hold on. Actually, that works out fine anyway. But over here in the recon agent, notice how we don't have any of those. Wait, if we look for the same expression here, wish I could just hit Control F, but the remote desktop catches it. Notice how we don't have any of those same expressions in here. We don't say the state is going to be equal to or appended to or anything like that in here. Now, what we do is we have placeholder variables while the function's instantiated that are going to hold all the data that we want to send back. And now we have blatantly, explicitly said, here is the data you're going to take and you're going to return, you're going to update, just like that. And if we don't define a reducer over here, right? So see now we have reducers for this one right here. So the host one, it has a reducer called host merge. So now it's going to, every time the data is returned for the host key, it's going to take this output host variable, pass it in as the new data in the reducer, and compare it to the current data, massage it, clean it up, and then it's going to return what actually goes into the state data. All right, let me try running this one more time. Let me see what it does here. It didn't like that. Actually, did we get... It looks like it loaded in the code, but is it actually executing? I don't think it is. I think actually I need to come up to maybe here. You know what? Let's just do this. Let's go. Let me grab the test data. We'll just rerun it from the beginning. Because it's not a very chunky run just to get through the return agent. So now the other benefit to this, Bobby, is when we look at these traces, like for example, we come down to like here. Let me just grab an example. And we look at the exploit agent here. So the exploit agent, we get all this stuff. So we get every single host returned back. We get every single task, right? We had to go through all of these tasks now. What we should see is that under tasks, when this comes out, right? This is the returned data down here. We'll see like just the one task that got modified or the one host that got modified in here. It makes the output so much skinnier. Like for this one right here. Nope, that wasn't it. I think it was this one. Let's see. So if we look at the output from the recon agent here, look at that. We've got such a smaller list of things in here. So it says, oh, hey, by the way, for task, we're just updating this one task with this ID in here. Yeah, so the new data should overwrite any of the existing data because we've made a copy of it. That was the other thing too, because we have this memory reference issue. Whenever we come through and we define these outputs, right? So what we have to do is if we just defined it as state host and pulled it out of here, what ends up happening is state host is an object. So now we're referencing that by memory reference. So we had to bring in a new library called copy. And this actually comes through and makes a what's called a shallow copy of the object and brings it in here. I suspect I'm going to have to actually do deep copies, but I'm trying shallow copies right now. So shallow copies just take copies of the variables, or basically takes it and puts it into a new reference. However, because that's an object. We do now have a new object with a new memory address existing in there. But that object then contains references to the other objects. So it's a big old nested heap of craziness. Damn, it's almost 11 already. Time goes by when you're debugging. I mean, this was not a horrible exercise to go through with updating the states and experimenting with the reducer. Ultimately, though, this was the perfect one to do. In fact, I think I'm going to rename this, actually. Instead of host merge, I'm going to call this a dict merge. We're going to merge the dicts. Giggity. Because it'll work just fine. And so this could be like our generic dictionary merge in here. And then if we need to do something specific, then we'll go bust out another reducer for any of these other ones in here. My brain's melting with symbolic linkage of objects. I know, man. Just think of it like it's using C pointers instead of using the actual. It's just abstracted it out. That's what it's doing. Oh, I forgot what I was doing. I was going to go get the test data and do one more quick run on this. So we can take a quick, brief look at it. So let me go back over to Stinger. Yeah. Run. And once it gets past the recon agent, I'll just nix it. One of the other things I need to do is definitely go implement a more robust nmap parser, because we're brute forcing it right now in a way it doesn't need to be done. We're outsourcing a lot of it to the language model. And it's a ton of XML, and this is not scanning a ton of data. So it would make more sense to go hard code in, lib nmap to it, and handle it that way. All right, so once it moves out of recon, I'm going to cancel this. We'll let it cook for just a second. The validator is validating that massive chunk of nmap data, and that's why it's doing that. It's taking so long. Oh, so we could be hitting an overload limit. Ooh. Bob, if you're still on, I like this one. Tools of the Trade. I gusta. Come on. I hope it's not timing out. It's been stuck on that recon validator for a minute. Something's messed up. I think we're stuck in a loop. Something is rotten in the state of HackBot. Because we should not have this many calls in here. Something's jacked. Let's see. These loops. It cost me so much. So let's see what happens here. So we hit the initializer. Stinger then passes down to recon. What does recon say? Action to perform TCP send scan on the target to identify open ports. And so it calls our nmap TCP scan. Nmap goes and scans it. Nmap returns our data back. Let me go double check something real quick. Okay, so it's still open. We should be good there. And then what does our recon output formatter come back with? Did it come back with what we had that was open? Yep, here's our host. So we have ports, protocols, scripts run. Yeah, everything looks good right there. And then we have host update. And then here's our host. Oh, I wonder if our host update is not working correctly. Yeah, I know it's not, in fact. So if we look at host update and we look at the output here, we get a singular host object back. Yep. So ooh, yeah, I know what's happening. So this is a problem in the validator node. So let's come down here to validator, because what are we returning, right? So we return the output host. Output host, if we track this back, is a copy of a particular host object right here. So we do have the target IP. So what we can do is we can actually return this. We have to modify the return here. So what we want to do is, in this case, we want to set this to target IP as the key. There we go. And that is the output host. So what happened is it was returning the data, but it was never making it into the host field. So we come over to the validator, right? And we look at the call here. Let's see. Like we can see, actually, here's the clearest place to see this. If we look at, here we go. Host data. We have nothing added to it. So it can't validate it because it's trying to make sure the data got into the host. Okay. So which ones are returning host data for us? Output formatter, it returns a host. Actually, it does not return a host. It modifies the task. Yeah, this one should be fine. Recon router, what about recon agent? It returns a host, but in this case, we're doing output host. Output host is a copy of the entire thing right here. So we're good there. We're returning a huge number of hosts in here. And in fact, we could even go through and modify this again. If we wanted to make this more clean, we wouldn't have to return the whole thing. We could just return the one that we're working on, and then it would merge it all in. Yeah. All right, I'll have to work on that next time. Let me leave a to-do here. Let's do some to-do action in here. So to-do, we need to update to return just the changed host. There we go. And if we really wanted to get kind of tricky with it, what we could do is when this host data gets returned. Actually, in this case, I take that back because we're not even returning hosts, are we? Yeah, we are down here. There's our output host. So if we wanted to get a little bit more slick with this, we could actually pass this to... Nope, screw it. It's not. If you're going to return just a host, then yeah, we need to do that. But that's fine. Yeah, because if you look at it here also, Bobby, is if we look at the trace to it here, if we look at like how much data is actually being used, right? Because we can see token level calls for each of these, right? So for example, here, stop changing, damn it. So here, recon, let's look at the initializer. Initializer uses 1,400 tokens, less than 1,500. Recon agent uses about 3,000. The tool node here doesn't use any, but the output formatter uses like 8,000 right here. And the input is 7.8K and like 600 out. So if we can take that and we can modify it to where we can chop it all down by having a dedicated nmap processor, it's going to be a lot better. And if it's not being used with nmap, then I mean, that's fine. We'll just have to have some way to go clean that up. All right, unfortunately, that's where I've got to wrap it up for tonight, guys, because I have to get some sleep. I have slept horribly and variably the last week trying to write this report. So let's go see if anybody's over on InfoSec streams. Nope. Oh, thanks, Gumby.
Incoming transmission from Marano Gumby. This is your nightly reminder to push it real good.
There we go. Cleaning up state management handling, still. All right. And because I always like to double check, let's make sure that actually did push. No, it messes it up whenever there is... where is it to push it in here? Yeah, there's my to-do. Push, there we go. Had to remember where to go to in PyCharm. Alright, so now it should show up here. There we go. All right, new code is updated up on the GitHub. All right, who can we go right over to on the big, beautiful purple site? Let's see. See, Griffin's on. Dude, he's been on for 6.5 hours. Man, dude's a machine. Let's see. Anybody doing anything fun? Nobody's on InfoSec streams. Hey, Starship, you have a great night, man. Happy Saturday and Happy New Year, everybody. Full contact blazing bits. What's up, Chris? Happy New Year, dude. All right, let's see. Anybody over in Science and Tech? Science is on. Let's see who else is over here. Let's see, Sid's on, he's doing some soldering. Bunch of earthquake monitors. Still waiting for the Jocko sponsorship train? Yeah, I know, man. Actually, I was really lucky because one of the guys, 8-Bit Oni, turned me onto that, and Vitamin Shop had them for $1 a piece. So I went and stocked up today. Let's see, who do we have on right now? What's Raggy doing? Dead Son is playing Minecraft. That dude's funny. Alright, we'll go right over to Griffin. Give him a good old raid. He's always doing awesome developer stuff anyway. Alright, guys. Unfortunately, that's where I've got to wrap it up. Woot. Let's get going. Everyone, y'all have a fantastic Sunday tomorrow. I'm going to be getting ready for traveling. I'm going to be out of town next week, so there's not going to be any news stream on Wednesday. But we're going to have some more fun tomorrow night. We're finished cleaning up the code, make it robust, which I think is going to be very important to do before we move into post-exploitation, because that's going to be the hardest of all the agents to go right. So it's moving along. We're having a great time. We're learning a ton. So everybody have a fantastic Sunday. I want you to know how much I appreciate y'all coming to hang out. And when you get into Griffin's chat, do me a favor, drop a bunch of Hack the Planets in there and just spam him. He's a good sport. What else like that? Oh, I forgot the most important thing, guys, which is, this is very important. I love you. Peace.